This video is about changing parent functions. So we're going to learn how to graph a parent function and make a change using a function rule. So a few things to remember. Whenever we have f of x plus a number, we are going to move the graph up that many units. Anytime we have f of x minus a number of units, we're going to move the graph down that number of units. So if the number is outside the parentheses and is added or subtracted, that controls going up or down. If the number is inside parentheses, so we have f of parentheses x minus h, we are going to move to the right h units. If we have f of x of parentheses x plus h, we're going to move the graph left h units. So this may seem a little bit backwards, but this is the original function. So in this case, we're just pulling out the h, whereas here we have to pull out a negative sign with the h. The last type of movement then is when we multiply by -1, we are going to reflect the graph over the x-axis. In order to do that, you can simply count how many spaces you are from the x-axis and then go that many the other direction. So let's work on making some transformations today. Number 1, given the graph g of x, sketch the graph g of x plus 5. So because the number is outside the parentheses, that means we are going to move up 5. So from each point on our graph, we're going to count up 5 spaces and plot a new point. Once we've plotted our new points, we're going to connect them so that the shape of the graph remains the same. Number 2, given the graph g of x, sketch the graph g of parentheses x plus 4. So because our number's in parentheses, this means we're going to be moving left or right. Because it's a plus 4, that means we're actually going to be moving left 4, because we would be taking a -4 out of the parentheses. So from each dot, I'm going to count 4 to the left and plot a new point. And then I'm going to connect them so that the shape remains the same. So let's try some more examples. Number 3, given the graph g of x, sketch the graph -1 times g of x. So this is a reflection over the x-axis. So when we reflect, we're going to go to each dot, we're going to count how far it's away from the x-axis. So in this case, this is 7 away from the x-axis. So now we're going to go 7 in the other direction, plot our point. For the next dot, we know we are 3 away from the x-axis, so I go 3 the other direction. From the third point, I'm 6 away from the x-axis, so I go down 6. And from the last point, we're 3 away from the x-axis, so I go down 3. So if your point was above the x-axis, when you redraw it, it should be below the x-axis and vice versa. So when I draw my shape, it looks the same, just that it was flipped, because a reflection is simply a flip. Number 4, given the graph g of x, sketch the graph g of x minus 2. So in this case, we are going to move each dot right 2 because we are inside the parentheses. So I'm going to count 2 to the right for each dot. And once I've got all 4 dots plotted, I connect them so that my shape remains the same shape. Number 5, graph g of x given, sketch the graph g of x minus 3. So because we're outside the parentheses and we're subtracting, this time we move down 3. So from each dot, I'm going to count down 3 spaces to plot my new point. And then I'm going to connect my points to form my new graph. Number 6, given the graph g of x, sketch the graph g of parentheses x plus 1 minus 6. Now in this problem, notice that there's 2 numbers, so we're going to do 2 different movements. For the number that's in parentheses, because it's a plus 1, that means each point is going to move left 1. And then because we have a -6 outside the parentheses, that means we are going to move down 6. So we can do both movements at a time because they are left or right movements. So from each dot, I'm going to go left 1 and down 6. left 1, down 6, left 1, down 6, left 1, down 6. And then I'm just going to connect my points to form my graph. Number 7, given the graph g of x, sketch the graph -1 times g of x minus 2. Now in this case, you have to be careful. Because there's a -1, you must reflect over the x-axis first. And then, because there's a negative or a -2 in parentheses, we are going to move right 2. You have to reflect before you move left or right or up or down. So first I'm going to go to this dot. I'm going to reflect, so I'm down 7, and then I have to move right 2. From the next dot, I'm 3 to the x-axis, so I go up 3, right 2. From the third dot, I'm 6 from the x-axis, so I go down 6, right 2. From the last dot, I'm 3 from the x-axis, so I go down 3, and then right 2. The reason that we reflect before we move left, right, up, or down is because reflection is multiplication, and in an order of operations, remember, we always multiply before we would add or subtract. So let's try one more with the reflection. So in number 8, the -1 is telling me that I'm going to reflect over the x-axis. And then the +5, because it's outside parentheses, that controls my up and down movement, and because it's a plus, I'm going to move up 5. So from each dot, I count to the x-axis first. It was 5 away, so I go down 5, and then I have to move up 5 to draw my graph in. So I end up on the x-axis in this case. The next one, I'm 5 away from the x-axis, so I go up 5 to be on the other side, and then go up 5 more, because we have to go up 5. The next dot, I go down 1 to the x-axis, so down 1, and then up 5. Same thing for the last dot. So they should end up level because I have this straight line. And then I just connect my points.